Sarah, I'm gonna need that time.
Caitlin, why you look like that?
So, once again,
Oh my god.
hi.
What are the materials?
Oh my god.
Norman, you're killing me. Any dark colored spice?
The salt work?
Materials?
Miss Ryan, where'd you steal my soap?
Salt work.
Everybody, what happens when you put salt in water?
Like your bird did on my bed.
It dissolves, right? So you can't use salt because it doesn't dissolve. All right, I'm gonna mute everybody back, but good morning. It's nice to see you all and hear you all. All right, let's get started. All right, so here we go. So you should have your bowl, all right, with water in it. Okay, and again, just fill it enough that I just made it so that it was high enough that when I put my finger in, it's taller than my fingernail. All right. And this lab, we're kind of, for 8th grade especially, going to review what we learned about with the properties of water. So if you guys remember, when we talked about water at the beginning of the school year, we did a couple really cool demonstrations where we were displaying the property of water tension, of surface tension, right? So we know that water, because of its polar molecules, right, it sticks together really well, and that makes it have really high surface tension, okay, which is why you can go ahead and take your pepper, all right, and we're just gonna sprinkle pepper on the surface. So I've got a pepper grinder, so I have to turn it, and it cuts up and releases the black pepper. You can put as much pepper as you want on the water. But notice that a lot of the pieces of pepper stay floating on the water, and that's just because of that really high surface tension that water has. It's gonna be strong enough to hold the weight of the pepper on top, kind of like some bugs, like the water strider, can actually float, right, or walk on water. We also watch the Jesus lizard, which can, or the basilisk lizard that can run across water. Again, that's because water has high surface tension, so it's gonna hold the pepper. All right. Now we're going to take our dish soap. So this has been going around this demonstration because, of course, everyone right now should be washing their hands, right? Yes, very good. All right, and when we take our dish soap, what we want to do is, how do I change it to me? All right, here we go. All right, so you just want to put the dish soap on your finger. All right, and you should have your bowl with pepper. All right, so if you aren't able to do this at home because you don't have pepper, then you can just watch my video, which everyone should be able to see right now. All right, so I put dish soap on my finger. We use soap to wash our hands because chemically, the properties of soap help to repel water so much that it can break its surface tension and allow us to clean any dirt or grime or oils that we could have. So what you're gonna do is with the dish soap on your finger, you're not going to take your finger and put it to the surface of the water.
I didn't mean to.
What the heck?
That was sick.
That was cool.
To the bottom.
Ryan is a waterbender.
That was really good.
Yay! So you can do it again if you want. So we can just keep doing it. If you put your pepper on again.
If it's sunk to the bottom, Aiden, that means you have terrible dish soap.
That means you have terrible.
The same dish soap as
No,
you.
it doesn't. All right, so go ahead and take it. You do it again if you still got the dish soap on.
Miss Ryan, are you a waterbender?
I didn't do it again, but it's
Miss Ryan,
fine.
we have the same soap. This is
I know, I love that, Austin. That's great. Right? So once you've got your soap now, demonstrate with this activity how effective soap is at repelling dirt, right? Helping to break it up and clean things off. So I hope you enjoyed it. So,
Can I drink it now?
what did we learn in this lesson? We should
That dish soap shoots.
Drink.
wash our hands with soap. Thank
Wash
you.
our hands with dish soap.
Oh, I'm sorry.
Donovan, drink it.
Drink it.
Drink it.
All right.
You should drink it.
So I hope that was fun. All right.
Drink it, you're a simp. If you don't drink it, you're a simp.
All right. You can go ahead and set your bowl to the side, grab a paper towel, and then we're going to get started with our science class. So we're going to head over to Nearpod. All right. So on Nearpod, I got 22 of you guys in there. If the rest of you could join. All right. So we're going to go back to talking about the sun. And yesterday we had our introduction to the sun. So we talked about all the different layers of the sun. There are 6 layers of the sun. 3 of them are denser and considered part of it, whereas the upper 3 are considered like the sun's atmosphere. So that's what we did yesterday. So today we're going to go back and revisit those different layers, talk about what's going on in each layer, how hot it is in each layer. And we're also going to talk about something called coronal mass ejections today. So that's basically like when the sun burps and releases a ton of energy. It's called a coronal mass ejection, or CME. So we're going to talk about how those influence us here on Earth, excuse me, and what are the different things that we can do, just knowing that they can impact us. So head over to Nearpod. I got 26. 27. All right, cool. So Curly, it showed like you disappeared. There you go. All right. All right. Oh, I'm so excited to see everybody. We have some that weren't here yesterday. So if you missed yesterday, yay, we got Lappy. Good. We got Wilmar. Nice. All right. So remember, I am giving you credit for showing up to these things. And again, today we are going to do activities in Nearpod. So that counts as your classwork. There might be some days where I give you an assignment and I only talk for a short period of time. But so far, I think Nearpod's going really well. So for today, that's what we're doing, is your activities in Nearpod count as your classwork. All right, yes, we're done with the pepper and the dish soap. So hopefully your fingers are now nice and clean. They smell nice. Okay, so we have most of our people in. Anyone else I'm missing, it might be because they got logged out. So I'm gonna get started. So good morning. So our topics for today is what's happening in each of those 6 layers of the sun that we talked about yesterday. So everyone should have your Nearpod up. You can put Zoom to the background, so hopefully you can just hear me. Okay, so we're talking about those 6 layers of the sun today. We're gonna talk about coronal mass ejections, which we call CMEs, and kind of should we be worried about them, because we're gonna learn about what the different things are that they can impact when it comes to them bombarding our planet, all that good stuff. Our first thing we're gonna do today is we're gonna watch a video. The video is only about 4 minutes. It's gonna go over, again, those 6 layers of the sun. And it's going to talk about in detail what's happening, the characteristics of each layer. I'm going to give you guys the ability to watch them on your own. So I'm going to mute myself so I can start watching my video now, but you should all be able to watch it on your own. And then once you're finished, we'll come back to the next slide for Nearpod. All right, so go ahead and play your video. All right, so sounds like most of us are finishing up, which is awesome. So there's a couple really interesting facts there. So when we talk about how hot the inner core of the sun is, or the core of the sun, the innermost layer, if you were listening to the video, they said that it is 15 million degrees Celsius. So if you think about how we know Celsius, remember that 100 degrees Celsius is the boiling point of water, right? If you want to compare it to 100 degrees Fahrenheit, 100 degrees Fahrenheit is about 39 degrees Celsius. So try to think 15 million degrees Celsius is a number. Once again, when we talk about space, numbers kind of lose their meaning, but 15 million degrees is like the hottest ever. When you talk about the other layers, though, notice that as you go from the core to the radiative zone to the convective zone, and then your first layer of the atmosphere, which is the photosphere. Photosphere translates to sphere of light. The photosphere is really the light we're seeing when we look at the sun. So you think of the photosphere as that layer is crucial because that's the one you and I actually see, right? That's where that light is escaping into space that you and I see here on Earth. The photosphere is actually cooler than the outermost layer of the atmosphere, which is the corona. Great timing for that word. The corona is actually over 1 million degrees. And that's something that a lot of scientists question how it's possible that the outer layer, which should be the coolest, is actually a lot hotter than the underlying layer. So that's another question that we're hoping to answer. All right, so next page of Nearpod. All right, so for this activity, I put together matching pairs. So you are going to, from the 6 layers that were just described in the video, you're gonna match them to their spot. I also threw in there prominence, sunspot, and flare. And remember from what we learned yesterday, those are behaviors that can happen on the outer layers of the sun. A prominence is a giant flaming arch, which is what someone said yesterday. So a prominence loops back. The magnetism in the sun causes these energy loops to appear. And as long as it stays connected and comes back, that's what we call a prominence. But sometimes there's so much energy flowing through a prominence that it's too much that the prominence loses its structure and it breaks. And that produces a solar flare. The other one is a sunspot. So a sunspot is usually partnered with a prominence, and it's a portion of the surface that's gotten cooler. And you notice that because of its darker color. So those for us appear as sunspots. Sunspots you can see depending on their size. It's possible to see them from here on Earth without a telescope, again, wearing protective eyewear. You could see one if there was one big enough. Sunspots can last for a long period of time or a short period of time, depending on how much energy was released. Chromo, when you think of chromo, like chromatography, we did a lab earlier this school year where we did chromatography. We took black marker and it had to be water soluble, so washable black marker. And remember, we put that on the filter paper and we let water separate the colors, right? Which is why it's called chromatography, right? Graphing colors. So chroma means color. So for the second layer of the atmosphere of the sun, it's called the chromosphere. And it's called that because it literally means a sphere of color. That's where we see lots of different colors kind of in that layer, which gave it its name. And then the outermost layer is the corona. The corona is very large and it can be seen during a solar eclipse. It's also incredibly hot compared to the underlying layers. I don't understand why people are saying their Wi-Fi died. If they're communicating, then the Wi-Fi didn't die, right? If you run into tech issues, okay. All right, I'm sorry. If you run into tech issues, you know, bear with us and, you know, just join us when you can. I'm always going to keep these sessions. I'm never going to go really more than 30 or 40 minutes. And that means from when we start. So I've been kind of giving us 5 minutes before we start. So really like 9:35 because I've been waiting for everybody with the tech and everything to get ready to go. So. Oh, Kyle. Wow, I had no idea. Okay. All right. So moving on. Nice job, everybody. I got some people that are still working. All right, so let's talk about the core. So again, the core is 15 million degrees Celsius. This is where the site of nuclear fusion is occurring. So you have to remember that you've got hydrogen is the fuel of the sun. So you've got hydrogen atoms in the core that under that gravity, that density, that heat, and that pressure are pushing together so hard that they actually fuse into a new atom of helium, right? You remember the atomic number of hydrogen is 1. The atomic number of helium is 2, right? So what you're having happen is the proton of a hydrogen atom, proton of another hydrogen atom, right? They're fusing together and they make that new atom of helium with 2 protons in it. This obviously releases a ton of radiation energy, which we feel on Earth when we go outside. Again, that takes what we learned yesterday, exactly 8 minutes and 20 seconds on average. If you were also listening in the video, almost have everyone done. If you're also listening in the video, they said that it takes about 100,000 years for a photon of light produced in the core to make its way up to the surface, right? Which means that the light we're seeing today is actually over 100,000 years old, meaning it was produced over 100,000 years ago, which is pretty crazy. All right, next slide. We're now going to talk about coronal mass ejection. So a coronal mass ejection is not the same thing as a solar flare, though they can be partnered together. So a coronal mass ejection is where plasma is getting sent outward from the sun. We see this when we see the aurora borealis. A coronal mass ejection is when you have a lot more plasma than usual that is hurling its way towards Earth. Our magnetosphere protects us from these harmful CMEs and solar flares. That's part of the reason why life can exist, because without Earth's magnetic field, we'd have this radiation hitting Earth's surface where life on Earth as we know it probably couldn't survive. So it's a weird reality, because if that magnetism suddenly went away, we would be exposed to a lot of harmful radiation. So check this video out. There are a total of 5 reasons why we should worry about coronal mass ejections. And one of those is they're very beautiful when you get to see that plasma dancing at the poles. The idea is that with a normal amount of flares and CMEs, our magnetic field can handle diverting them away at the poles. But if you do have a large enough CME, it can penetrate through our magnetosphere and it can impact a lot of our electronic and technology devices. So check this video out. So at this point, I'd like everyone to play the video. All right, thanks guys. All right, so from the video, there was five reasons you should care. One of those was they're very pretty when you get to see the Aurora Borealis. But besides that one, what were some of the really important things that they shared? I'm gonna try this. I'm gonna try this where I'm gonna scroll, and wherever my mouse lands, that person has to answer. Nice. Okay. So how can these coronal mass ejections influence us on Earth? So one more time, how do CMEs impact us on Earth? Scroll. Haley.
What? Wait, what was the question again?
All right, so the question was, how do CMEs influence us here on Earth?
Our cell phone service.
Okay, very good. Our cell phone service. What else? There was another one that was really important. You got half of it. You're great. So yes, cell phone service would be impacted because we have satellites, which are how our cell phone signals bouncing off a satellite to connect us to the person we're trying to talk to, and a cell tower next to the person we're trying to talk to. So yes, but what else? I believe it was the last one, and it was talking about how we keep the lights on. Do you want me to go to somebody else? You did great. Nice job. All right, this is fun. Where's it gonna land next?
It's not fun.
Marcos.
Yo, what's up? I was just eating crackers.
All right, Marcos, what was another way that CMEs can influence us here on Earth?
They can expose you to harmful amounts of radiation.
Very good. What did they say about keeping the lights on?
I'm not really sure. I'm not sure about that one. Also, I mean, it makes everyone's flights late because they rerouted it to the north.
Say it one more time. Sorry.
It made their flights late because they rerouted it to the north.
Yeah, so when you think about airlines, very good, Marcus. When you think about airlines, right, they're much higher above our surface. So their technologies to operate that aircraft can be influenced by CME. And that obviously can be super dangerous if it compromises the ability of the aircraft to fly, right? So if the radar and the other instruments on the airplane, die or get fried from the CME, then obviously that's super dangerous to anybody on board for it to be able to land safely. Another thing they talked about is power grids. So when we talk about electricity, all right, stay with me. Yes, he's eating crackers. All right, stay with me. So when we talk about electricity, like FPL, for example, Florida Power and Light, they're responsible for our electricity staying on. CMEs can influence and fry some of our diverters and some of our electrical equipment, which could mean a bunch of people could lose power. So not only would you lose cell phone service, but you could lose power for days, right, to be able to replace all that equipment that gets fried by a CME. So no electricity would be really bad, right? And then no way to communicate would be also very bad. And obviously, no power means no Wi-Fi. So that would make communication nearly impossible for the world that's been so reliant on, instant communication. All right, nice job. Next slide on Nearpod. So we just talked about this, but how can these solar storms affect Earth? So I'd like everyone to have at least two parts to their answer.
Can you mute? Oh wait, never mind. I just want to eat crackers.
Sorry. How do I go back to this? Help. Some other things that you could talk about would be this can also influence astronauts that are working on the International Space Station. So obviously that's something to take into consideration for NASA. So this is something that they're always monitoring because they know that obviously the astronauts on the ISS, we do have ways to protect them from radiation, but if it's too much during a CME, they would be exposed to that harmful radiation that could lead to cancers or things for these astronauts. And also remember, a lot of this is unknown. We've only had astronauts on board the ISS for 20 years, right? So when we talk about CMEs and the history that we know that they can be much stronger, right? We really don't exactly know how bad it could be, depending for the astronauts on board. So that's another concern is astronauts. But most importantly, for the mass impact of the planet, it would be definitely our communication in the form of cell phones, and then electricity. Nice job, everybody. Nice job. And again, these things are constantly being monitored. So by NASA and by electrical companies around the world. In 2012, we called it doomsday. Everybody thought the world was going to end in 2012. And one of the theories as to why, obviously it didn't, nothing happened. But one of the theories as to why that was going to happen, most of the reason why was the Mayan calendar was ending in 2012. That's just because the Mayans didn't go further than 2012 in their calendar, but people took that around the world as like, oh my gosh, the world's going to end because the calendar's ending. People's theories as to why or how we could have a serious impact on Earth that would be like a world ending or apocalyptic event was a CME. And that's because during that video that we just watched, we knew that there was a potential that CMEs and solar storms could be picking up in those years, right around 2012. And if all of our cell phone communication, electricity went out, that could be a really bad thing for the rest of the world, of course. So that was one of the theories, was that a CME was going to take out all of our technology, but I'm glad it didn't. All right. The final thing I wanted to do today is to play quizzes. So the game code, you should be able to join. I tried adding the link this way, so I wanted to see if that works. Oh, nice. Great. Awesome. All right, that should be everyone, I believe. No, we got 39. Okay. The real test is going to be if we can play Quizlet live. All right, I'm still waiting on 5 people. All right, everyone, and this is our last thing for today. So thanks for staying with us. Okay, I'm missing 4 more. Does anybody have any questions while I'm waiting for all these people to get in that I can answer about kind of what we're doing here, or any issues that people might be having with technology? I'm pretty sure if you didn't get to submit, I can still see it. I'm sorry about that. I didn't mean to cut you off. Ashton was here, so I'm not sure what the deal is there. And like I said, you guys are all getting credit for being here. And I hope this is bringing a little bit of normalcy to your lives during this bizarre time. So I'm excited we still get to do this together, because I don't know about you, but Netflix is getting a little boring. Yes, if you haven't yet, just be prepared that we are going to be using Google Classroom as our primary platform. So if you do not have that set up on a device, then we can figure that out. Also remember that Miss Cheney and GSOTA is prepared to loan devices out during this time. So if you are having issues with your home devices, like they're not reliable or they're glitchy or whatever the issue is, we can provide you one. You just need to have your parent contact us, set up a time to come in, and then we'll loan the device to you. You'll have a contract, obviously, that you're taking, responsibility for the care of the device. But like I said, if you're having any issues with your own technology at home, if it's not reliable, then just let us know and then we can set you up with it. Obviously, the Chromebooks would be reliable for this kind of stuff. All right, let's get started. All right. We didn't talk about Einstein's E equal mc squared, but that has to do with light and talking about the speed of light. So sorry about that. We will get to that in our next lesson. I love the mix of classes. This is fun. job, everybody. All right, so while people are still working, some of the most missed questions, nice job, everyone. Let's go over these together. This question should have said, sorry, what is needed for fusion to occur? And the answer is high density and high temperature. So think that the fusion happening in the sun of hydrogens turning into helium, right, means that you've got gravity of the entire solar system crushing down on those atoms to get them to fuse together. So incredible temperatures. Remember, the core is 15 million degrees Celsius, which is a number that's hard for us to even contemplate. But that high density from gravity, high temperature is what's needed for fusion to occur. How many Earths could fit inside the sun? So we listened to that in the video today, but the answer is about 1 million Earths could fit inside the sun. Okay. Energy is created in the core when two hydrogen atoms join together to form a helium atom. Again, that process releases the heat and light that you and I feel when we step outside. This one question said, in which area of the sun does gas rise as it's heated up and then fall back down as it cools? And that would be convection. So that'd be in the convection zone. One of the most missed questions was when we look at the sun, what layer are we viewing? And this one's called the sphere of light because it's the light we're seeing. So it's called the photosphere. So I think the photosphere is that underlying layer of the sun's atmosphere. So it goes photosphere, chromosphere, corona. So photosphere is closer to the actual surface of the sun, which we consider the convective zone. And the photosphere is the sphere of light you and I see. So when we're looking at it, we're looking at the photosphere. In the eclipse event, a lot of us got this one right, but it said, which layer can we see in that picture where the eclipse, the moon is blocking the sun, right? And that big, wide, right, rays that we see around it is the corona. So corona is actually huge, right? It's millions of kilometers across or outside of the sun. The sun is mostly made up of hydrogen. Our sun's halfway through its life. So until it runs out of hydrogen, right, for now, it's fusing hydrogen atoms into helium atoms. So think like when the sun runs out of hydrogen, that's going to be when our star dies. Don't worry, that's in like billions of years. But when it dies, it's going to be because it's out of hydrogen. And then it's going to start fusing heavier things like helium atoms. And then we start making carbon and everything all the way up to iron. All right. So label part 3. So in that diagram, you're looking at the inner part of the sun. So the innermost part is the core. Then after the core, you have the radiative zone. And then outside the radiative zone, you have the convection zone. Right? So the answer to that question was, for number 3, was the convection zone. So the next question, I think that was most of them. You guys did a good job. Yeah. All right, everybody. I was trying to talk to, is Jaden still here? All right, everyone. That's it for today. I think you guys did awesome. Thank you so much for checking in. I hope you have an awesome St. Patrick's Day. Go do a jig or something. I am going to record these so that I can post them on YouTube in case we have people that missed anything. But any questions or anybody need anything, let me know. Send me an email. Rely on Google Classroom as the primary way to communicate. Always be checking in there. It should be partnered with your email, so it should be sending you messages, right? Whatever we post stuff. Yes, took a while. But I think she's finally getting bored that no one's giving her attention. Can you say hi? Can you say hi? Say hi. I know. We'll go outside. Thank you. All right. Thank you, everybody. Everyone say bye.
Bye-bye.
Yo.
Ryan.
Science class.
Hello,
Bye, everyone. Bye.
This
Bye.
is science
Bye.
class. We're
Bye,
learning
bye.
the anatomy of a dog.
Hi, Miss Ryan.
It's supposed to be the anatomy of a sun. All right. Bye, everybody.
Ryan.
Bye.
Bye.
Can I get a cereal?